All right, another question on static equilibrium. We want to look at two force members and what are the forces on two force members going to look like. So here's a real simple two force member. Okay, and I'm gonna have a pulley and with my right hand, so your left side. So there's a force on the left and a force on the right. So the question becomes, if this is in static equilibrium, there is a restriction on these forces. So here's an arbitrary force right and an arbitrary force left. If these forces aren't equal and opposite, it's going to be accelerating. So I've got to have equal and opposite forces if I'm going to do this, right? And there's only two forces, hence a two-force member. But the other thing that's true about this is, let's say they're equal and opposite as they're shown here. This is going to cause a rotation, right? Because of the way this is oriented, this is going to rotate like this. So in order for there to be no rotation of this two-force member, if there's only two forces acting on this member and there's no rotation, those forces have to be equal and opposite and along the line of the two-force member, right? So there F, and there's, I'm going to call it minus F because this is in the positive direction, this is in the negative direction. Now that's not too bad when the shape is nice, but what about when the shape is not nice? So here's another potentially two-force member, right? So let's see. Make sure this looks right. So I'm going to grab up here and grab down here. Now, if these forces are not equal, it's going to accelerate. Okay, the sum of the forces won't equal zero. So they've got to be equal and opposite in direction. But if one is up and the other is down, again, I'm going to cause a rotation. And so they've got to cancel out, but it's an odd shape, right? But the same idea is going to hold. As I go with equal and opposite forces, and one's down here in this lower right section and one's up here in the upper left, what has to happen is the forces must form a line and they have to be along that line. So if this is F over here, this is minus F over here, and they have to be along that line. Regardless, it's going to be regardless of what this shape is. So I could have all sorts of funky shapes there. But if there's only two forces acting on it, then we're going to have them in equal and opposite directions. Okay? So don't worry about the shape, but they got to be equal and opposite. They could both be in, but in this case, they're both out. It doesn't matter. Okay? All right. If you have any questions, leave them in the comments below. Thank you.